We have a floor equation to solve, so let's briefly talk about an important property of the floor function. So let y be a real number. The floor of y, without even talking about what it really is functionally, is always going to be an integer. It's always going to return an integer. All right, so I'll put z there. It's always going to return an integer, for sure. Now, an example of that would be, let's say we do the floor of 6.8. And y'all, this is called the greatest integer function a lot of times because it returns the greatest integer that's less than or equal to the input. Okay, so the floor of 6.8 would be equal to 6. All right, and again, 6 is the greatest integer that is less than or equal to 6.8. Okay, but the big idea here is that the floor function always returns an integer. And so let's take a look at a concrete example, and we'll play into that property in just a minute. Notice here that 45 is between 7, and I'll put 7 to the first power for emphasis. 7 to the first power, or 7, is strictly less than 45, but 45 is strictly less than 7 squared, which is 49. Okay? And so since we are talking about the logarithm, which is the inverse of the exponential function, this 1 that you see right here is exactly why 1 is the floor of log base 7 of 45. Okay? Because 1 is meets the conditions of the floor function. Okay? Now, but notice that this is not equal to if you substitute 45 in right here to the right-hand side of the equation, 45 over 3 minus 15, which is just the right-hand side of the equation we're trying to solve. That's equal to 0, right? So 1 certainly doesn't equal to 0 in any form of arithmetic I've ever seen. So that means 45 is not a solution. Okay, so let's write that, just 45 not a solution. And let's see, I'm not sure what the customary abbreviation is, maybe SOLN. Let's spell it, why not? Okay, solution. Okay, but we've learned, based on just the structure of the equation and this property of the natural log function, that any solution must be a multiple of 3. Okay, any solution, x must be a multiple of 3 to satisfy this equation. That's crystal clear because the left-hand side is always an integer, so the only way the right-hand side could be an integer is if x is a multiple of 3. Now this trivially implies there's no solutions between 0 and 1. This is the interval 0, 1. And we're starting there, folks, because the logarithm function has a domain 0 to infinity. All right. So there's clearly no multiples of 3 between the real numbers 0 and 1. All right. So we don't have to worry about that interval, but let's take a look at a solution and then see if we can reason through that this is one solution, and I think there's one other solution. But notice that this is equal to 1 because 48 is between 7 and 7 squared, just like before. And it's also equal to, if you remember the right-hand side of the equation, it's equal to 48 over 3 minus 15. This is equal to 48 over 3 minus 15, right? 48 over 3 is certainly 16. 16 minus 15 is 1. All right? So 48 is a solution. 48, let's just put a check there to call it a solution. All right, now, and notice that's consistent. Oh, that should be 7 to the first power there. Sorry, let me erase that. 7 to the first power. Okay. Now, let's bump along and check for some other solutions here. Notice it'd be easy to verify that you could pick other multiples between 7 and 7 squared, other multiples of 3, but they wouldn't have a floor of 1 because of the right-hand side, right? We know that 48 would be the only one with that property, right? The linear equation has a unique solution, right? So let's take a look at the very next multiple, okay? We could try log base 7. The very next multiple would be 51, right? Now notice 51 is larger than 49. All right, and so this is equal to 2, right? And of course that's because, and let's write it out, 7 squared is less than 51. 7 squared is 49. But that's less than 7 cubed. And again, this is just in keeping with this general truth about the relationship between the floor of a log, log base 7 and then the exponential statement, okay? All right, so we have another solution here, folks, because this is equal to 51 over 3 minus 15. And I'm not able to keep this on the same screen very well, but 51 over 3 is 17, right? 51 over 3 is 17. 17 minus 15 is 2. So we have another solution, 51. And you can see that just by the nature, if you go up to floor level 3, you're talking about 7 cubed, right? And so that number is going to be way too big for the linear function. And you guys can verify that. It's an easy verify that these are the only two solutions, 48, and I'll write it, I guess, I'll try to write it in solution set form if you want. 48 and 51 are the only two solutions. And again, you guys can verify that if you try to go to floor level 3, you're talking about numbers in the between 7 cubed and 7 to the 4th, which will be too big for the linear function on the right-hand side. Okay, and I'll just say that without writing anything down. So anyway, this is our solution set right here, 48, 51. Let's come up here so you can see it in its entirety. And again, it wasn't super rigorous, the approach here, but once you get past floor level 2, like I said earlier, you're talking about, floor level 3 or higher, you're talking about numbers that are larger than 7 cubed. 7 cubed is what, 343 or something like that? Or let's see, 7 is 740. Yeah, I think 343. Notice that there's no way you're going to get 343 over 3 minus 15 being anywhere near 3, right? So that's why these are the only two solutions, 48 and 51. I hope you enjoyed that. I liked it. It's kind of fun working these problems. This problem would be a little more challenging if I made it the floor of the log function equals the floor of the linear function. It's a little bit more work to do something like that. But if you have a linear right-hand side, it kind of limits the choices. And the logarithm function outgrows the linear function, the exponential function outgrows the linear function by such a super rate that you know you're done when you're done. All right, so again, final solution there. Thank you for viewing.